Okay, class, today we're going to talk about confidence intervals for the mean when the standard deviation of the population is unknown. So like yesterday's formula, it's very similar, but instead of the standard deviation of the population being used, we are going to use the sample size standard deviation. So in this slide, it shows S sub x. Basically, just have an S is fine. Okay. So the distribution is symmetric about the mean. The mean is 0, the median is 0, the mode is 0. So it's very similar to the standard normal curve. The distribution's shape just depends on what's called the degrees of freedom, which is n, your sample size, minus 1. Okay. So the higher your degree of freedom, the closer the curve gets to the standard normal distribution. The area under the curve is still 1. Okay? All right. So this is the chart you were given. So when it says find the critical value T sub C for a 95% confidence level, really easy. You're going to go to 95%. The sample size is 15. So what is our degree of freedom? 14. We're just going to subtract 1, okay? So we're going to take that degree of freedom, go to 14, go over, where does it intersect with 95%? That's your T number. 2.145. That's all you have to do. Okay? So the degree of freedom is always the number of your sample size minus 1. You go to that, intersect with your confidence level. That's your critical value. Easy enough? Easier than the probability chart we have for the normal curve. All right. The margin of error. Again, very similar from yesterday. You're going to have your critical value that you found using your degree of freedom and your confidence level times your sample standard deviation instead of your population standard deviation. It's the sample standard deviation over again your square root of n. Jacob. Yeah, that's just regular n. Yep. So you're dividing by the square root of your sample size. Do not take the 1 away from that. Okay? So it's almost the exact same formula as yesterday, except we're talking about a sample standard deviation. And your t-score is from the distribution, t-distribution chart. Alright? So again, this is going to be used when we do not have the population standard deviation. Okay? The t-distribution is when you do not have a population standard deviation. Good? All right. So here's your guidelines. First thing, you want to identify your n, your sample size, your mean, and your sample standard deviation. If you are given a chart, remember how you have to find your sample standard deviation. Take each value, subtract the mean, square them, okay? Add them all up, divide it by n minus 1 because it's a sample, and then take the square root. That's your sample standard deviation. So you have to remember how to do that from chapter whatever that was, okay? Identify your degrees of freedom. It's always n minus 1. Find your error. And then again, you're going to add and subtract that from your mean. And find your left and right intervals. Or endpoints. Okay? So you have your steps. Alright. I think there's at least 1 or 2 on your homework where you have to find the standard deviation of the sample. Okay.
Ready?
All right, here we go. We're going to try it. You randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is 162. The sample standard deviation is 10 degrees. Construct a 95% confidence interval for the population mean temperature of coffee sold. Assume the temperatures are approximately normally distributed. So figure out your N. What is your N? 16. Figure out your sample mean. 162. Figure out your sample standard deviation. 10. All right, let's go. So get your T chart. What is our T sub C? So we're going to do this. Let's write down what we already said. So we are looking at that chart, and we're going from what's our degree of freedom? 15 over to 95. We're looking at 2.131. Okay. What is going on here? All right, so our margin of error is going to be 2.131 times our sample standard deviation divided by the square root of the sample size. So using your calculators, what do you get? I get 5.3275. What you get? And then we want our confidence level. We're going to take the 162 and we're going to add and subtract the 5.3275. I'm going to round a little bit. So our coffee shops should be between 156.7 degrees and 167.3 degrees. That's your interval of the temperature of the coffees. Pretty easy. Okay. Let's try one more. Okay, you randomly select 36 cars at the same model that were sold at a car dealership and determine the number of days each car sat on the dealership lot. The sample mean was 9.75 days. Sample deviation was 2.39 days. Construct a 99% confidence interval for the population mean number of days the car model sits on the dealership lot. So go and do again. Okay, your interval should be between 8.67 and 10.84 days. All right, you randomly select 25 newly constructed homes. The sample mean construction cost is $181,000. The population standard deviation is 28,000. Assuming construction costs are normally distributed, should you use the standard normal distribution or the t-distribution, or neither, to construct a 95% confidence interval for your population mean construction cost? Which one should we use? The standard normal. And again, this is the difficult part when you get a take-home quiz or a test, determining which one should I be using. Okay? What do you got, Grace?
We should use the confidence interval or for the standard normal distribution because you have a population deviation of that sample.
There you go. You've got the population standard deviation. They gave it to you. And it's normally distributed, therefore you can use the standard normal distribution. Okay? If it wasn't normally distributed, if they didn't put that little blurb in there, you couldn't use either because we were under 30. We're under 30. All right? So it's got to be over 30 or normally distributed. And then whether you have the population or sample. So you have to think about all those. All right? That's it, guys. So you have the rest of the